So we are going to talk today about trend lines. All right, so we're going to talk about how when you interpret the graph, what those lines shapes end up actually meaning, and kind of understand a little bit about what those relationships mean as we're talking about graphs. We're also going to then practice putting a trend line into that measured data so that we can have a calculated relationship between those measured points. And it will be a curve fit, but please do not misunderstand the words curve fit to mean curvy, right? You can curve fit a straight line, right, for a trend line. Okay, so anyway, we'll talk about that in just a little bit. Before we do, though, we just need to kind of make sure that we're all on the same page about the meanings of line shapes and what they mean. Okay, so first off, if we have a horizontal line, that means that the variable, the y, right, your ordinate, the thing that you thought was going to change, is not actually changing as your dependent variable changes, okay? The slope of a horizontal line is 0, right? Its derivative is 0. And the area under that curve, and yes, the curve is straight, the area under that curve is increasing at a constant rate, okay? So therefore, its integral is increasing as at a constant rate. Conversely, you can have a vertical line. And what that means is that as you are changing your dependent variable and you're going along, all of a sudden, that independent variable instantaneously changes once you reach a given dependent variable. So the slope of a vertical line is undefined or infinite, right? The area under the curve is 0 because it goes straight up, right? But what you normally see when you see straight lines is you see one of two things. You either see this like red line that is straight, or you see this blue dashed line that is straight. And so when we're talking about the red line that is straight, the derivative is constant, it is non-zero, and it is positive. Okay, that's the derivative of the red line. When we're talking about the derivative of the blue dashed line, it is constant, non-zero, and negative, or decreasing. Okay, which means that the integral of the red line is increasing at an increasing rate of increase. And for the blue dashed line, the area is still increasing as you move along, but it is increasing at a decreasing rate of increase, okay? Then you get into like actual curves, all right? So when we've got this kind of U-shaped up curve, right, concave up, that means that the variable, that y, is increasing at an increasing rate, so its slope or derivative is positive and increasing. The area under the curve is increasing at an increasing rate. And so therefore, like, that's why it ends up having that shape. When you have the curve that's concave down, though, yes, the variable is now increasing at a decreasing rate, so the area under the curve is increasing at an increasing rate. Because the area under the curve is the integral of the variable, the slope now is positive and decreasing. So that slope would be that positive and decreasing kind of slope as it decreases in magnitude. Now, when the slope is negative, you get the flip side of both of those curves, right? So when the slope of that derivative is negative with a decreasing magnitude, the area under the curve is still increasing because it's still getting bigger. It's just getting bigger at a decreasing rate when you're concave up with a decreasing trend. And then when you're concave down with the decreasing trend, that variable is decreasing at a increasing rate, meaning it's decreasing faster and faster, right? And that the slope of this is negative with an increasing magnitude of the absolute value. Right? And that area is increasing, but at a decreasing rate. Okay, so why do we care about the line meanings? Because sometimes your data is going to be given to you in chart format, right? You're not going to necessarily be given a point in time with numbers. So for here, we have a light bulb that was turned on for 15 seconds, right? So the total energy absorbed by that light bulb is shown with this particular graph. And at time 15, the energy does not change, right? So let's deal real quick with the power beyond 15 seconds. What do we know about power? It is indeed energy over time. So that means that power is the slope or integral of this energy line. What is the slope between 15 and 20 seconds? Zero, right? It was turned off, and so therefore there's no more energy being supplied. So from 0 to 15, the way that you figure out that integral of the energy is you take the 375 and you subtract off the initial at 0. Does everybody see that the y-intercept right here is down there is 0, 0? And you take the 15 minus 0, and you end up getting 25 joules per second, which we know is a watt. Exactly. So we have 25 watts of total energy absorbed by this light bulb. Okay? If we had this graph of velocity and time, and we know that velocity is indeed distance divided by time, right? We know that the integral of velocity is what? It's distance. It's distance, right? That is the area under the curve, right? And the derivative is acceleration. That is the slope of the velocity line, all right? So, if we had to describe various points of the line by either saying they were 0, positive and constant, positive and increasing, positive and decreasing, negative and constant, negative with increasing magnitude, negative with decreasing magnitude, or that it could not be determined from the information given in the graph. If we had a question saying about acceleration between points A and B, and reminding ourselves that for a velocity graph, acceleration's the slope of the line, right? What can we say about the slope of the line between A and B?
Positive and constant.
It is indeed positive and constant, right? So, between points B and C, the acceleration is 0, yeah. And between points C and D, negative and constant, right? If it were increasing or decreasing, then you'd get a curve instead of a straight line. Okay. So, now reminding ourselves that distance is the area under the graph, right? The integral. What would we have between points E and F for our distance? It's the distance, right? So the area under this graph, okay? From E, it is positive and increasing, right? As we go from E to F, we are adding area under that graph, all right? So it is positive and increasing, okay? So if we go from point F to point G, the distance between those 2 points is doing what? Okay, it's not negative, it's positive because it's still adding area. You would be subtracting area if it was negative, right? And so we have positive and increasing area. And it is increasing at a rate of increase, but it is, they don't have that as a option. So positive and increasing is what we would say. All right. And so between G and H, right, the distance now is not negative. We're still adding area, right? Distance is the integral. It is the area under the curve. You're still adding area as you're going through here. You're just adding area at a less rate of increase. Yes. So it's all positive and increasing. It's just that the rate of increase here is constantly increasing and the rate of increase here is constantly decreasing. Okay. All right, so what does that mean? Because on Excel, there are really three main types of trends that we're going to use, right? We're going to use linear trends that have the form like y equals mx plus c. And that would be that linear positive and linear with the negative slope, right? We're going to use the power function where it's y equals b times x to the m power. And we will use the exponential function where we have y equals b times e to the mx power. That e, of course, is related to the natural log, right? Now, just so you know, the notes on Blackboard do, after this slide, have literally how to add and edit the trend line, as well as how to add and edit the power line, as well as how to add and edit an exponential trend line. But we're going to go and do that ourselves by going to the actual demo file that you started with ICA Q5. Okay? So make sure you open that up. And the first things first, right? It's no longer the previous day. It is now the 23rd for us, right? And our purpose is now no longer for ICA Q5. Our purpose is to demonstrate, if I could demonstrate, trend line options in Excel. All right, so now we're demonstrating trend line options in Excel. And you put these three charts in there, but in order to be able to see and work with them appropriately, we're going to move the charts to their own sheets by moving them to a new sheet. Like example A, we're going to move to a sheet called EXA. Okay, we're going to go back to the starting data tab, go to example B, move that chart to a new sheet that is called EXB, and move back to the starting tab, go to example C, and move that chart to a new sheet that is called Surprise of All Surprises, EXC. Yay. I know. We are super creative in engineering, just maybe not with our names. Okay. So, back to example A. When we look at the data series, right, and you click on it and stuff like that, you get this lovely little flyaway marker, and we can see that our markers are kind of small. So when we go over to the marker portion of the format data series and the marker options, we want to make sure that that is not 5, but really it was more like 12 that we had said was good last time, right? When you right-click on the data series, you can add the trend line through that flyaway, or if you just go through and from your chart tab, You can go to add chart elements and add particular kinds of trend lines, and it does kind of auto show you some things as you're doing it. But and indeed, you can even add a trend line by going to the little plus like we did before and down to the little trend line option, and it kind of brings up a little weird random trend line, right? But I don't like doing either of those other two ways because they just seem kind of complicated to me. And in order to save time during a test, I just like that right click and add trend line. Okay, let's get rid of that. Okay. All right, so when you right click and add trend line, now over here your flyaway is format trend line. All right, and you can see that linear now lies in between all of the data. Excel kind of auto defaults to linear, and you can see that the spread of data is nicely scattered around linear, but let me just go ahead and show you that over here it does the exact same thing, where if you change to exponential you get kind of a wiggle up. If you change to logarithmic you get kind of a wiggle down. Polynomial doesn't look like it really does much. Power kind of get a little bit of wiggle. Moving average really looks like weird. So I think we can all agree that it's probably linear, right? Especially since we have a relationship between pressure and temperature. And we know that the ideal gas law is PV equals nRT, which follows the same format as Y equals mx plus b, right? Our trend line, right? When we've got linear, we want to always, on a trend line, make sure that we display the equation on the chart. And when we do display that equation, we want to make sure that it is, that the trend line label ends up being the same size of font size as our axis numbers, which we had said last time from the graphing file was either 4 or 16. And so when we do that, when we have the things highlighted, right, and we make it 14, come on. There is another way to go in and do it this way. Nope, there's not. Okay, come on. 14. Okay. There we go. Whew. When you don't have things clicked on Excel exactly properly and you've got too many things clicked, you can just hit escape and it will usually fix things. Oh, but now that I've made that 14, I notice my numbers aren't actually 14. Oh no. Oops. So need to go make sure that our numbers are indeed 14. And if previously on your X or abscissa you did not have the axis bounds be from 360 to 520 with major units of 20 and minor units of 5, now is the time to do that. All right. And then we also want to make sure our axis titles are bold and 2 points greater than the numbers. So in this case, that would make it 16. Bold and 16. All right, now that looks better. Before we go into manipulating the label, I want to go back to the trend line to format it, because we always want to do all of our formatting first. As soon as we start messing around with the label itself, it will divorce it from the trend line and it will stop updating. Because like right now, if we change to exponential, you see my trend line equation changes, right? So I'm going to change it back to linear because that's what we had decided on. And if we look at the equation PV equals nRT, there is no B or constant, right? Whether you y equals mx plus b, y equals mx plus c, whatever that plus whatever is. There is no plus in the actual theoretical equation. So over here on the Format trendline, trendline options with the chart option. At the very, very bottom, just above set display equation on chart, or excuse me, display equation on chart is the set intercept button, and we want to set that to 0 because there is no constant in the ideal gas law, right? If there were a constant in your theoretical equation, you would totally leave it in, all right? But in this case, there's not. Notice that when I click on that set intercept, it also changes the slope of the line ever so slightly. It goes from 0.0056 to 0.0058. I mean, it's a very slight wiggle, but the wiggle is there. All right. So once you've done your manipulations there, we also want to go to the bucket on format trendline because Excel kind of auto enters this weird orange dotted line that does not coordinate with our data at all. You always want the trend line color to be the same color as your data markers, which in this case was blue, right? And instead of dotted lines, let's change the dash type to the short dashes, okay? And we had said before when we were talking about theoretical data lines that they needed to be between 3 and 4 points of font. So we need to update this width from the little skinny mini 1.5 to 3, pausing at 3 to take a look. That looks okay. If I go up to 4, that's starting to look a little chunky. So I'm going to go back down to 3. So that it's nice in proportion to the data points. Okay, now that we've got our trend line looking appropriately, now we can come format the trend line label. In order to format the trend line label, first of all, you'll notice that you can kind of see the grid lines behind it, which could make it very difficult to read. So we always want to make sure that under the bucket, under the trend line label options, we fill it with something nice. This is the border part of the bucket, isn't it? Yeah, that's the border part of the bucket. We want to fill it with a border that is the same color, and then we want a solid fill that's not black, because that blacks out the thing. We want a solid fill that is white. And then we can come up here to the home ribbon and change the color of the font to match the color of our data and put it bold so that it stands out. Okay? It is easiest to change the font from the home ribbon, and it is easiest to change the background and borders from this format trendline label flyout. Okay? And then the last thing we want to do with the trendline label is we want to make sure it's near but not on our trend line. That's a little close. All right, there you go. Come on. And that is a matter of making sure instead of that you get the little kind of grabby buttons. All right. And so there we have a properly formatted trend line for our pressure versus temperature data from example A. And we can go back to the starting data tab now, and we can fill in that trend line as the linear, because it was linear, and it was indeed from the ideal gas law. Please do also add the parenthetical note that you need to either explain the offset from a linear equation, i.e. why the theory says it's supposed to be there, or if you have some sort of uncertainty through either the measured quantity or instrument error or something. I mean, there could be reasons, is what I'm saying. There could be reasons for that plus B plus C, at which point, if you had a report where this chart was going to be a little 2x3 image in a report, you would explain that. Otherwise, you set that trend line equation equal to 0 with the intercept through the trend line options. Okay? So that lets us move on to example B, which is our green triangle data series. And we learned from example A that our axes numbers are going to be a little small, And so we want to make sure that they're not so titchy small and that they get nice. And I'm going to choose 14, which means that my axis labels are going to end up being 16 and bold, and 16 and bold. All right. We are going to do the exact same thing as we did where we took the marker and marker options and change the size of that marker back up to like 12 so that we have nice big markers that are in proportion to the rest of the data. And oh, somehow that didn't update to 16. I accidentally picked 10 instead. All right, okay. So now we've got a proper plot using all of those good plot things. Yay. Fabulous. Why'd that go? Okay, all those proper plot things. When we right click, or when we escape. All right. When we select our data and right click, you get that same add trend line for the flyout. And again, there are other ways to get your trend line. If you're in a situation where time counts, you know, the flyaway box is easiest. Now notice, again, like I said, Excel is going to automatically give you linear orange dots. And as you look at the spacing around the green triangles, you'll notice, I mean, well, it could be linear, but when we look at the axis of volume and radius, how is volume usually related to a radius?
Cubed or squared?
Volume is usually equal to pi r squared times h if we're talking about a cylinder, or r cubed if we're talking about a sphere. So it's probably not linear, right? If we look at exponential now, that remember has the e in it, and I don't remember saying anything about, I said pi, but I didn't say anything about e. So we probably want to come down here to the power equation, and oh my, look how that magically looks really, really nice, right? Because it matches the theory. So that's a good thing, right? There should be some scatter of data around a trend line, but in order to be a good trend line, you should have a nice look to it. And on this trend line, on the chart options, remember we want to scroll down to the bottom of the flyout, and we want to check display equation on chart. Okay? When we do that, our equation shows up, but before we start messing with the equation, we're going to go over to the bucket, and we're going to change that color from the little ugly orange to green. Oops, that was the wrong kind of green. Change it to the same color green as what we had before. That line width, again, needs to be between 3 and 4, whatever it takes to look nice. I think this one could be just a little bit bigger, 3.5. And we want to change this dash type. Let's use the long dashes for our dash type. All right, and that gives us a nice trend line that looks like it goes through just about every single data point. All right, and now we can focus on our label. So the first thing we do when we click on the label is we want to make it match in size to our axis numbers, and we want to go to the bucket, and we want to make sure that the in the bucket part that the fill is a color. And I know last time we made it a white color. You can also make the fill be green and make the text be white and still bold. And so this is kind of the inverse or vice versa of the first one. It's just kind of a nice stylistic choice that you can sometimes make, especially if you know your equation is going to be in a color PDF kind of format. All right. Now we need to move our label off of the trend line. But wait, we said this was a power equation, and right now that power says it is 12.502 times x to the 2.027 power, right? And that's really close to that volume of a cylinder where it was related through pi r squared and a height. So over here under the Trendline label chart option, you'll find that there's a number where you can change the category from general, which is just kind of auto, it lets Excel do whatever Excel wants to, and you can go to number, and it usually either automatically comes up to 2 decimal places or whatever the last decimal place was that you picked in this particular worksheet. And that brings us better off, but if we go ahead and change it to 1 decimal place, right? Because on a power, you're usually going to use either 0 or 1. It's always a good idea to go ahead and check one versus the other, because with 1 decimal place, we now have 12.5 as our m, right, our constant, and 2.0 as our power. When we change to a decimal place of 0, that 12.5 became 13. And so that gives me just a little bit of pause, a little bit of like, maybe that 12.5 was kind of important, so go ahead and put it back at 1. And it is okay to have like a point something in your power. Indeed, if something is raised to a power of 0.5, it's a square root, isn't it? Right? Okay, so if the theory merits it, you can leave that sort of stuff in. Okay? And then finally, we have a radius r and a volume v. We do not have an x or a y. So we want to go into our Trendline equation and change that y to a capital V, because that is indeed the symbol according to the axis. And we want to go over to the x and change that x to the capital R. And then at this point, if the point 0 really does bother you, you can mouse over and you can delete off the point 0 off of the 2. Right? It doesn't bother me, so I'm going to leave it in. All right. And now we have our equation for our line in the symbols that we're talking about. It's near but not crossing. Did I forget to do that? Oh, I did forget to do that. All right. Okay. So over here, we should have changed y to be p, and we should have changed x over here to be the capital T. All right. Oops. All right. So, yes, we've got that equation, and we can go back over to our starting data, and now under the trend line, we can write that it was a trend line for power. Come on. Trend line for power, and the theory behind it being a power trend line is that it is a cylindrical volume. I will say this. Power trend lines are not going to be an available option to you if within your data series you have any zeros or negative numbers, right? So please do add that note that it's not available for negative or 0 values in your data series for that power. Okay? All right. So that was the power trend line for the green triangle data series. And now when we pop over to our example C, we've got the same issues as before where we need to make our axis numbers be bigger, and we need to make our axis titles be bigger and bold, and title be bigger and bold. And we also need to make those data markers on the data series be, with the marker options, up to a marker size of like 11 or 12. 12's a little excessive, so let's go back down to, 10 looks good. All right. So now that we have it properly plotted, we're going to do that right click, adding trend line, And again, Excel, like I said, is going to automatically give you a linear orange dotted trend line. If we look at that power curve that we just were looking at, because you can see that there's kind of a slight curve to this data, when we look at the power curve, it's not quite fitting the data that we have. So there are some other options, one of which is exponential. And oh, how convenient is it that this data series matches the third thing we were supposed to talk about? Yay. All right, so now we have an exponential trend line. We already know that we don't want it to be orange. We want it to be purple. And we know that from our graphing that we want it to be about a 3.5 will look good right here. And then the dash type, let's try a dash dot. No, just dash dot. There you go. Not long dash dot. It's hard for me to see sometimes what I'm selecting when it's in dash dot. So now we've got a nice purple line with the purple dash dots, but we're not done because we forgot to put the trend line. So you do have to click on the chart portion in Format Trendline Options, Chart. So bucket is for formatting, chart is for like actual Excel-ness of it. And we're going to click on that display equation on chart. Incidentally, statistically speaking, that R-squared value, that is a statistical like definition of goodness of the intercept, which we don't need for this class, but you may need in your future like life. So yes, it's a goodness of fit metric. All right, so on this trend line label, right? I in this one made my labels be 16, so I'm going to do the 16. Label option, we want to make sure that it's got a solid fill. This time I'm going to go back to traditional white fill with the purple border. Come on, if I can get it. Come on. Purple border and the purple text that is bold. All right. So yes, formatting the label like right now on like single trend lines for single data series is a little trivial, but you can imagine if it were multiple data series, having it formatted to the exact same color as everything else does help. At least the people who aren't colorblind, it helps. And so that's why we also want to make sure it's located near but not on our trend line. Okay? And so if you had another trend line down here, you would have its label down below so that it wouldn't get confused. Now, let's talk about this trend line label reasonableness, right? So right now, if we go over to the chart option on the trend line label options, and we change the general to be a number format, we'll see that with 2 decimal places, we get 20.07 equals e to the negative 0.10, right? Which is probably okay. But if I switch it to 1, that just looks better, right? For an exponent, you probably want either 1 or 2 decimal places. There could be, if you were working with highly scientific lab data with specialized equipment, there could be an argument made for having 3 decimal points in a relationship. But as you can see, it didn't give us any extra information on our exponential powers constant. So we're going to go back to the 1 decimal place here. And what we have here is voltage related to time. So now that we've done all the formatting, you do, again, all the formatting first, because if you go in to change the labels itself within the label box, you divorce that label from the trend line itself, and then if you were to go back and change the trend line, you would have, well, actually what you would have to do is you'd have to delete the trend line, add a whole new trend line with a new equation that was actually attached to the trend line. And so again, time. You want to save the actual changing of your y and x variables to the very, very end. So y here was a capital V, right here for the symbol. And x here is a lowercase t. So as you move along the label, make sure that you do not change the e. This e is part of that natural logarithm exponent, right? That we do not want to, we're not changing the e, we're changing the x to be a lowercase t for the time down here, okay? And indeed, when you have voltage kind of decreasing over time, what you really have is something that is close to what's called a capacitor discharge. So I'm going to pop right over here real quick. A capacitor discharge actual theoretical equation is the voltage across the capacitor is the constant of the supply voltage raised to the exponent's power of the negative time over RC, where time is the lapse time and RC is the time constant of the capacitor. But all that to say that when we go over to our starting data tab, we can say that, yeah, it makes sense that this trend line is exponential based upon the capacitor discharge theory that actually literally has an E in the equation, right? And again, exponential trend lines are not going to be available for values that are less than or equal to 0. So negative numbers, if there's negative numbers in this data series or if there's zeros in this data series, it won't show up on that flyout, okay? And remember, this still says ICAQ5. Excel is mean. If you don't save as, right? Remember, this is now no longer ICAQ5. This is our demo file Trendline for section XX, right? And if I save that, now I can save it, and then you can close it, and you can upload it to Blackboard. No, Excel. Upload the Excel to Blackboard because this is a demo file and we need to see all of the tabs as we go through and check that you did indeed have the purpose and you wrote in all of your fun and fabulous notes.